6.5 is the quadratic formula. So how many of you guys have seen the quadratic formula in Algebra 1? Hopefully all of you are raising your hands, right? You've all seen the quadratic formula. Do you remember what the quadratic formula is? Yeah, it's right in front of you, so hopefully you do. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Do you note to some songs? I think maybe Michael does because he's like bouncing and singing back there. So do you know it to Pop Goes the Weasel?
I don't know what I know to.
Yeah. So we'll be learning some different songs today, some unique songs. But let's start with how it's related to completing the square, because the way we got the quadratic formula is from completing the square. Okay, so I'm going to show you how this is. I often make this a bonus point in the test, so if you want to really get that bonus point, then pay attention to how this is done. Okay, so it says, how is the quadratic formula related to completing the square? So if we start out with a quadratic function, so ax squared plus bx plus c, and we set it equal to 0. When we complete the square, we always need a 1x squared plus bx equals c, right? So what we're going to do is we're going to subtract the c over. So we're going to have ax squared plus bx equals negative c. And we want our x squared term to have a 1 in front of it. So what's our next step then? What do we have to do? We divide everything through by a. So when we do that, we have x squared plus b over a, x equals negative c over a. So when we complete the square, we do what we call have it and square it. So we take the b term, we divide it by 2, and we square it. Okay, so we're going to take the number that's in front of our x, we're going to divide it by 2, and we're going to take that result and square it. Okay, so when we do this, Zach, you good? So we're going to do b over a times 1 over 2 squared. So we're going to get b over 2a squared. Okay, who will know this answer? Logan, how about that? You. All right, so if I have b over 2a and I multiply it by b over 2a, well, what do I get?
B squared over 4a squared.
Exactly. Do you guys all see that? B squared over 4a squared. So we multiplied b over 2a by itself. That's what we're going to add to both sides. So we're going to have our x squared plus b over ax, and we had our negative c over a before, and we're adding b squared over 4a squared. So we added that to both sides, just like completing the square. So don't let it freak you out that there's variables, right? That there's a's, b's, and c's instead of numbers. We're doing exactly the same process that we did yesterday. So when we do this, we've now done what we called completing the square. This should be a perfect square trinomial, right? So it should factor into something times itself. Okay, so let's think about it. So we have x here, right? X plus something. What's the second thing? X plus what? Yeah, exactly. It's always what you had when you divided by 2, so it's right here. That's what goes there. Because we take the square root, right? We can go back to that. So we have x plus b over 2a. And this is all equal to whatever negative c over a is plus b squared over 4a squared. So we want to combine these two terms. But we can't combine those fractions because the fractions don't have the same denominator. You can see. So it's just like if I had the fractions like 1/2 plus 3/5, we would need to get common denominators. That's what we're doing here. Okay, so we have to get common denominators. So if I have negative c over a, and I want to get common denominators with b squared over 4a squared, what do I multiply negative c over a by on top and bottom? 4, and not just 4. A. Do you guys see it? Because that's going to give me 4a squared on the bottom. So we're getting close. It doesn't look like it yet, but we're almost there. So if I have negative c times 4a, I get negative 4ac, and then plus b squared, and it's all over the common denominator 4a squared. All right, so we're to that point in the quadratic, or in the completing the square, where we have something squared equals some kind of number. Okay, so how do I get rid of the square? Square root. So we're going to square root both sides, and we're going to write plus or minus. So we have x plus b over 2a equals, we're going to do plus or minus of the top and bottom. So I'm going to have plus or minus the negative 4ac plus b squared. How do I write that in the quadratic formula? Is that how I usually write it? No, usually I write b squared minus 4ac, right? And then it's all over the square root of 4a squared. So when you have a square root over a big fraction, we take the square root of the top and the square root of the bottom. That's how we did there. So Eric's noticing that the bottom, if you take the square root of 4a squared, we do get 2a, right? So we are almost there. If we're solving for x, we have one last step. How do I get the x by itself? What do I get rid of? Yeah, subtract that b over 2a over. So I have negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. So we have common denominators. So our final answer is negative b plus or minus the square root of b squared minus 4ac all over 2a. Oops, that's a c there. And that's the quadratic formula. So it comes from completing the square. That's how we get it. Kind of cool, huh? All right, so that was probably a little bit overwhelming for some of you. That's fine. Every year people are like, what just happened? This is like a proof in Algebra 2, right? You guys remember proofs in geometry? Same kind of thing. So we just proved that the quadratic formula is real. It comes from, you know, I went to grad school for proofs, so don't whine about this little 2-second proof because I wrote a 26-page proof of something. So I don't even remember what it is, and I wrote 26 pages about it. Yeah, Cole?
So when you say this would be like a bonus question on a test, would you have to recreate all of that information, or would you just have to do?
Yeah, I would basically start with this, and I would say, show me how you get the quadratic formula by completing the square. Okay? So if you guys need to rewatch the video, you can go through and you can watch the video again. Huh?
You're gonna list it on the test?
Yeah, for a bonus, yeah.
Okay.
Yeah.
So we won't lose points if we don't know.
I used to put it on the test. I used to make people do it. I used to be more mean, I guess. I don't know. All right, so here we go. So number 1, so I have 0 equals 8x squared minus 22x plus 15 using the quadratic formula. Okay, so if we're solving this equation, we need to first identify what our a, b, and c are. So a is going to be 8, b is going to be negative 22, and c is going to be 15. It's just the coefficients, right? It's just the numbers. So you guys all see it. 8, negative 22, 15. Kind of like if you're doing synthetic division, it's what would go on the right side or backwards out. All right. So I always recommend on your homework to write the quadratic equation down, because the more times you write it down, the easier it is to memorize. So I always write it down. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And then we just plug things in. So I'm going to have negative b, so negative 22 is positive 22, plus or minus the square root of b squared. So I'm going to take that negative 22 and I'm going to square it. Now what I typically tell my students to do is just go ahead and do that in their calculator first. Okay, so go ahead and find negative 22 and square it. So when you do that, you should actually get a positive 484. A lot of people will mess that up when they do that because they put negative 22 squared in your calculator just like that, and it tells you negative 484. Tell me why your calculator is lying to you and telling you negative 22 times negative 22 is a negative number. Exactly, you would need parentheses, right? So I always have students every year, they're like, wait, my calculator says that's negative. I'm like, no, negative times a negative is a positive, right? So you will always have a positive number right there. Okay, that's why I just go ahead and I square it out, so then people don't make mistakes when they're put it in the calculator. All right, so then I have minus 4 times a times c. So 4 times 8 times 15 all over 2 times 8. Okay, so we're going to go ahead and find that inside. So we're going to do 484 minus 4 times 8 times 15. What'd you get? You got 4. Did you get the square root of 4 there? What is the square root of 4? 2. So I have 22 plus or minus 2 all over 16. Okay, and we end up getting 2 answers. So the first one involves the plus, and the second one involves the minus. So if we have the plus 2, then we get 22 plus 2 is 24. 24 over 16 reduces. They're both divisible by 8, so we get 3 over 2. All right, and the second one, if I use the minus, then I get 22 minus 2, which is 20, over 16. They're both divisible by 4, so we get 5 over 4. Those are the two answers. So just like with completing the square, if you didn't have a square root answer and if you didn't have an I answer, then this would have worked if I factored in the original one. So you could easily factor that and get the right answer. Okay, so completing the square and quadratic formula aren't really like, we don't really use them for the ones where we get nice rational numbers, fraction numbers, okay? We use them more often when we are getting, like square root answers or I answers, okay? All right, so next up. So find the zeros of 2x squared minus 16x plus 27 using the quadratic formula. So identify A, B, and C, so do that first. So we should have A is 2, B is negative 16, C is 27. We write our quadratic formula so that we slowly memorize it, right? Do any of you feel like you have it memorized now? Yeah, good. All right, so I have negative b, so negative of negative 16 is going to be positive 16, plus or minus 16, or negative 16 squared. Do you guys know that? 16 squared? I know you do, Karen. Yep, 256. My friend Mr. T at Sycamore makes students memorize all of those. Up to like 20, right? Yeah, good. All right, so when I do this, I have 256 minus 4 times 2 times 27. And you can put that all in your calculator all at once. When we do, we get the square root. Yes, his name is Mr. T. Do you like that? Yeah, Kate thinks that's the coolest name. Are you imagining Mr. T like from the A-Team? Is that what you're imagining? As teaching math?
I was thinking he was either Mr. T or Kim Rose that died this summer.
Mr. T is still around? That would be funny if we had Mr. T, like the, yeah, I pity the fool, that guy teaching math. Yeah, he looks nothing like that. All right, so I get 16 plus or minus square root of 40. How do I simplify square root of 40? 2 root 10, yep. All over 4. All right, and now we have to reduce out. So you can't, don't do this. A lot of you guys try to do this. We cannot do that, right? We can't just cancel from two terms because we have a plus or minus in between there, right? So you can do the little heart thing if you want, and you can reduce out all of them, but you can't just reduce out 2, okay? The heart thing's like where that 4 goes in all of the different pieces. So basically, like what I think of the doing, like if I had 16 plus 2, let's say x, divided by 4, what we're doing is we're pulling out a 2. And then we're reducing, which is allowed, right? So the easiest way to do this is to look at these 3 different things and divide them by what they all have in common. What do they all have in common? 2. So I'm going to divide all of those numbers through by 2. So we're going to get 8 plus or minus, you can write 1 root 10 or just write root 10 all over 2. And that's our answer. So their GCF was 2. Okay, so same idea here. So it says solve negative 4x squared equals 3x plus 1 using the quadratic formula. So now we have to get it all on one side, right? We need it 0 equals ax squared plus bx plus c. So I'm going to add that over. So I get 0 equals 4x squared plus 3x plus 1. And I identify my a, my b, and my c. So it doesn't matter if you decided that you wanted to subtract the 3x and subtract the 1 over to the left-hand side. Like you could have a as negative, b as negative, c as negative. That's fine, right? So if you did it another way, that's fine. All of the signs will work out in the end. Okay, so we write down our quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So I get negative 3 plus or minus the square root of b squared is 9 minus 4 times a times c all over 2a. So 9 minus 4 times 4 times 1 all over 2 times 4. So we get negative 3 plus or minus 9 minus 16. 9 minus 16. So negative 7 all over 8. So what do we have? Ah, we do have a solution now. It's just not a real solution. We have an I thing, yep. So if I have the square root of negative 7, I write that as I root 7. Okay, pretty easy. It's not hard. Just write that I on the outside. So it's going to be I root 7 all over 8. And then this one doesn't have like a GCF or anything that we reduced down by. So we're good. We can leave it like that. Does this make sense? Feeling okay with this stuff? All right. So it can look a little bit more complicated. This one looks more complicated, right? All right, so we're going to go ahead and distribute the 5x in. So I have 5x squared minus 15x. And then distribute the 4 in. So plus 4x plus 16 equals 31 minus 7x squared. 31. All right. And we can get it in that form, in the quadratic formula form. So I'm going to add the 7x squared over. So when I do, I get 12x squared. And then I have negative 15x plus 4x. So that makes negative 11x. And then I have 16 minus 31, right? Subtract the 31 over. So we get negative 15. Okay, now it's in the form that we like. Okay, so we can use quadratic formula. You could try to factor if you want to, but we'll do quadratic formula since this is what the section's on. So I'm going to have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I get negative 11, so 11 plus or minus the square root of b squared, so 11 squared, 121, minus 4ac all over 2 times a. So we have 11 plus or minus, and you can find the inside, it ends up being 841 all over 24. And 841 is actually a perfect square. So if you take the square root of 841, you get 29. So we're going to have 11 plus or minus 29 all over 24. So in this case, we can go further, right? So we don't have a square root, we don't have an I, so combine them. So when we have 11 plus 29 all over 24, what do we get? So we're going to have 40 over 24, which they're both divisible by 8. So we could do 5 over 3. Or you could do 2, and then 2 again, and 2 again. And then the next one, if I do 11 minus 29, negative 18 over 24. And they're both divisible by 6. So negative 3 over 4 would be the other one. So this is one that would have worked with factoring too. All right, does this make sense? You get it? All right, so the next little bit says find the quadratic equation that has zeros of 1 minus 2i and 1 plus 2i and has a leading coefficient of 6. I forgot to put these on your homework, man. I like these ones. All right, so remember when we had like zeros of like 2 and negative 5, we would write it as x minus 2 and x plus 5, and then we'd FOIL it out, and we get this polynomial. We did that on your last homework, right? So, all right, so same idea here. So we're going to set it up, and we're going to set it up as x minus each 0. So we're going to have x minus 1 minus 2i. Okay, and I'm going to put a big parenthesis around it. And then I'm going to do x minus 1 plus 2i, because that was the other 0. And I'm going to put parentheses around it. And we'll worry about the leading coefficient of 6 at the very end. Okay, so this looks kind of complicated. We have parentheses within parentheses, right? So we're going to distribute the negative n and distribute the negative n. So when we do that, we have x minus 1 plus 2i and x minus 1 minus 2i. Okay, and we need to find the polynomial. Yeah. Yeah, basically, like we don't call it FOIL because there's like 3 terms times 3 terms. But we do that distributive property where we take the x and we multiply it into everything, take the -1 and multiply it into everything, and take the 2i and multiply it into everything. So are we ready? Can we handle it? Your brain's going to explode? I don't think it's going to explode. I think you can handle it. All right, so we're going to take that x and we're going to multiply it into all 3 terms. So we're going to have x times x is x squared, x times -1 is -1x, x times -2i is -2ix. Okay, and then we take our -1 and we multiply it into everything. So I have -1 times x is -1x, -1 times -1 is +1, -1 times -2i is +2i. And then we take our 2i and multiply it into everything in the second polynomial. So 2i times x is 2ix, 2i times -1 is -2i, 2i times -2i is -4i squared. And then we combine our like terms. And magically, a lot of these things will go away. All right, so we have -2ix. Well, we had positive 2ix. We had positive 2i. We also had negative 2i. And then what was I squared? I squared equals what? -1, right? So we can make that x squared minus 1x plus 1. And then this is -4 times -1, so it's +4. So we end up getting x squared minus 2x plus 5. Then our last step is we want a leading coefficient of 6. So we just take all of that and we multiply it through by 6. So our final function, so you can do y equals or f of x equals, is 6x squared minus 12x plus 30. So that has zeros of 1 minus 2i, 1 plus 2i, and it has a leading coefficient. The number out front is 6. Can you handle that? Fun stuff, isn't it? You guys are like, this is way too early for this kind of stuff. Can't handle it. Now, some of you guys are going to be like really super smart and you can handle the shortcut. But some of you guys are going to see the shortcut and be like, say what? So I'm going to show you a shortcut. So do you guys remember when you have, you're like, I'm not even going to listen. No, you guys can do this. Do you guys know when you have like x minus y times x plus y? When you FOIL it out, what should you get? X squared minus y squared, right? And so when you see something like that, you kind of ignore all those middle terms because you know the outer and inner end up canceling anyway, right? That's like the difference of 2 squares. Do you guys remember that? Okay, a lot of things just canceled, and the reason they canceled is because of the difference of 2 squares. So let me show you. So if you had, what was it, 1 minus 2i and 1 plus 2i as zeros, you set it up the same way to start with. You do x minus each of them. And then you distribute, so you have x minus 1 plus 2i and x minus 1 minus 2i. But you treat that x minus 1 like a variable. So if I had w plus 2i times w minus 2i, do you guys see that like the outer and inner would go away? Those are gone, right? Do you guys get that? We have w squared minus 4i squared. Do you see it? So yeah, so basically the outer and inner would go away, and we'd end up getting w squared minus 4i squared. That's what kind of happens here. This first part ends up being x minus 1 squared, and then the last two multiplied together end up being minus 4i squared. And x minus 1 squared, we can find that. We can do x minus 1 times x minus 1. And negative 4i squared ends up being plus 4. So you end up getting x squared minus 2x plus 1 plus 4, which is x squared minus 2x plus 5. And then that's done. Kind of cool, huh? So you can kind of eliminate all those i's. Okay, if you don't understand that, that's fine. You can always do the thing where you take the x into everything, the 1 into everything, and so on. And I can work with you outside of class if you really want to learn that. All right, and the last thing we're going to talk about is called the discriminant. not determinant. We're not going back to chapter 4 and doing matrices. It's called discriminant. And it's used to determine the number of real roots of a quadratic equation. So it's the part that's under a square root in the quadratic formula. Okay, so it says the discriminant of the general equation, ax squared plus bx plus c equals 0, is, so it's the part that's under the square root. So it's the b squared minus 4ac. So let's think about it. If I had, the equation and I said x equals negative 4 plus or minus the square root of, and b squared minus 4ac ended up being 0, how many answers would I have there? I have more than 0. I just have 1, right? Because I'd have negative 4 plus 0 over 2 and negative 4 minus 0 over 2. It's still the same thing as negative 4 over 2, right? Do you guys understand that? Well, what if I had gotten like 8? Then there'd be 2 answers, right? But if I had a negative 8, then there'd be no real answers. There'd be 2 complex answers, right? So that's what the discriminant tells us. It tells us the number and then the type of answers that we have. You could also talk about whether they're rational or irrational. So if I had, plus or minus the square root of 25, that works out and I don't have a square root anymore, right? Square root of 25 is 5. So we'd have rational answers. All right, so it says if d is greater than 0, the quadratic equation has 2 real zeros. If d is less than 0, the equation has 0 real zeros because both of them are complex, or imaginary if you like that word better. And then if d is equal to 0, the equation has 1 real zero, or 1 real solution if you want to say solution instead. So find the type and number of solutions for each equation. So if I have x squared plus 36 equals 12x, I subtract my 12x over. Oops. So x squared minus 12x plus 36 equals 0. And it didn't say to find the solutions, it just says find the type and the number of solutions, right? So if I look at my discriminant, which is b squared minus 4ac, my b is negative 12, so I'm going to do negative 12 and I'm going to square it. Minus 4 times 1 times 36. And I end up getting 144 minus 144. So I get 0. So my discriminant is 0. So that means how many answers do I have? 1, right? So I have 1 real solution. Because it means I had the plus or minus 0, right? And plus or minus 0 is the same answer. All right, so same thing here. So if I find the discriminant, I'm going to do b squared minus 4ac. So I'm going to have negative 10 squared minus 4 times 3 times 10. So I get 100 minus 120. So I get negative 20. So now my discriminant is a negative number. So if you have a negative number, then how many real solutions do you have? 0. 0 real solutions. Right, they're both complex. And same thing here, if I subtract my 12x over, then I get b squared is negative 12 squared minus 4ac. So I get 144 minus 120. So I get 24. So how many solutions do I have there then? 2. 2 real solutions. Okay, so it's just finding how many solutions you have. Okay, and you guys kind of see those solutions for that last one would be not rational, they'd be irrational. They have a square root. Because the square root of 24 doesn't come out evenly. But if that had been like 25, then it would be 2 rational solutions. So you could go even further, and a lot of textbooks will go and break that up further. Okay, and then the last one, I think this is the last one, maybe not. Oh, there's 2. All right, so it says Rebecca throws a shot put at a track meet. The height y of the shot put in feet. T seconds after it's thrown is modeled by this. So how many seconds pass before the shot put hits the ground? So remember, we've talked about that before. It goes up, it comes down. So we want to find when the height is equal to 0. So y is the height. So we want to find when y equals 0. So we just have 0 equals negative 16t squared plus 24.6t plus 6.5. And we just solve it using the quadratic formula. So I would just be careful, though. If you use the quadratic formula, I wouldn't say x equals. Do you guys see why we don't use x equals in this case? What's our variable? Yeah, we should use t equals, right? So we're going to say t equals. And we're going to have negative b, so negative 24.6, plus or minus the square root of b squared, so 24.6, whatever that is, squared, minus 4 times negative 16 times 6.5, all over 2a, so 2 times negative 16. So we get negative 24.6. Oh, let me just do the 24.6 squared minus 4 times negative 16 times 6.5. So, and if I take the square root, ooh, it's kind of gross. So I'm going to keep it under the square root because it's going to be like a decimal that goes on forever. Okay, so I have those two. So I have negative 24.6 plus the square root of 1021.16, and then divide by negative 32, and I also have the one with the minus. Okay, so I'm going to find the decimal versions for both of these. Okay, so do this along with me on your calculator. Do most of you guys have calculators where you can go up and grab the answer? Like you can grab what you had? No? All right, so if you don't, you can always store items. So it might be easiest to store this inside part as A. I don't know if I've talked about storing this year with you guys. Have I talked about that? So along the left side of your calculator, there's a button that says stow. All right, so I'm going to do the 1021.16, and I'm going to hit stow, and then I'm going to store it as alpha A. So let me show you how to do that. Okay, so if I have the 1021.16, okay, I don't know if you guys can see what I'm typing. It's kind of hard to see this screen. And then you guys see the button on the left-hand side of your calculator that says stow. So it's right here. So I hit store. And it does a little arrow. And you can save it as any letter. That's why you guys have letters on your calculator. I know that you guys like to write like little funny things on your calculator to your friends. But we're going to do alpha, and then A is right below it. Okay, and hit enter. So whenever you want that number, you can just do alpha A, and it will come up. So if you don't have one of those calculators where you can just push arrow up and it will come up and grab the number, you got to learn that store trick because you're going to use it a lot. All right, so we're going to do negative 24.6, and we're going to add it to A, so add it to alpha A, hit enter, and divide by negative 32. So I get negative 31.1425. All right, do we think that that's the answer? No, it's not going to take negative 31 seconds, right? Doesn't make any sense. All right, so, oh, did I forget my square root? I did forget my square root, but that's okay. It's still not a negative. So negative 24.6 plus, let's do the square root of A, and then divide by negative 32. It's usually something small because it's like if she dropped it backwards, how long would it take? And she wasn't very tall, so it shouldn't have taken long. Okay, so we get t equals negative 0.22, what was it, 22986. So we'll do 230. I usually do 3 decimals. All right, and then we find the other one. So when you find the other one, we're going to do negative 24.6 minus alpha A. No, wait, alpha square, or it's square root of alpha A, right? I keep forgetting that square root. And then I'm going to take that and divide by negative 32. So that one's 1.767. Does that make more sense? So that's how long it takes to hit the ground. Okay. And then the last one just kind of talks about how long it takes for a car to stop. I kind of have a story about this. When I was 16, I did something very stupid, and my friends and I were out like late, and we had a curfew by our parents, and so we were trying to get back to my friend's house where I was going to spend the night, and we were like, oh, we got to make it, we got to make it. And so we, I mean, teenagers do this. You all make stupid decisions, right? So we made this stupid decision, and we saw a cop up in the, like, far in the distance, and we're like, we're going to turn really early. And I wasn't driving, my friend was, and so she's like, oh my gosh, we're going to cut behind this school. And so she rips the car around, and we turn. And as we turn, we're in like a red convertible. and we like hit the curb, and thank God, like we should have. I don't know how we didn't flip over. Like we totally could have died. Like we just hit the curb, and the car was like totally destroyed. And so we called her dad, and her dad came to the scene, and we were like, there was a dog that ran in front of the road. And her dad was like, uh-huh. And her dad was a policeman, and he started measuring the tire tracks on the road, and we were like, oh my God, we are going to die. And we got in huge, huge trouble. So you never lie to your parents in the first place, right? That's the moral of the story. And you never lie, especially to a parent who is a police officer who measures tire tracks and said, oh, you guys were going like 60 miles an hour when you decided to turn. What happened? And we were lucky that we didn't get into your parents are not going to mind if you call them and say, see, this was before the time of cell phones. That was the problem, right? So if you call your parents and say, I'm running a few minutes late, it's okay to be running a few minutes late. We weren't doing anything wrong. We were good kids. We just were being stupid, like being very stupid. All right, anyway, so highway safety engineers can use the formula D equals 0.05 R squared plus 1.1 R to estimate the minimum stopping distance D in feet for a vehicle traveling R miles per hour. If a car is able to stop after 125 feet, so that's basically if you can measure the tire tracks and you see that it's 125 feet, what is the fastest it could have been traveling when the driver first applied the brakes? So you can just plug in D was 125. That's the distance, right? And we're going to find its rate, so the speed. So you do 0.05 R squared plus 1.1 R, and we subtract that 125 over. And then we solve. So we're going to have A equals 0.05, B equals 1.1, C equals negative 125. So I get R equals negative B, so negative 1.1, plus or minus the square root of B squared, so 1.1 squared, minus 4, A is 0.05, C is negative 125, all over 2A. All right, and then we find this answer. So 1.1 squared, well, let's go ahead and, do the inside part first. 1.1 squared minus 4 times 0.05 times negative 125. So I end up getting the square root of 26.21 all over 2 times 0.05 is 0.1. And we find both answers. So you can store that answer if you want. So negative 1.1 plus the square root of 26.21. Take that answer and divide by 0.1. So this gives me two answers. So the first answer is 40.196. And the second answer, if I use the minus, negative 1.1 minus the square root of 26.21 divided by 0.1. That one gives me a negative answer. So negative 62.196. So that one doesn't make sense, right? We're not going backwards. So that's our answer. And that was in miles per hour, I think. Is that right? Did I say? Yeah, miles per hour. All right, make sense? All right, stop. Oops.